Hello and welcome to the channel. If you're new or if you've been around for a while, thank you tons for being here. This video is all about zero clearance inserts, throat plates, whatever you want to call them. This is the factory one, a lot of space around the blade, right? There's pros and cons to that. You get more vacuum with space around the blade, but sometimes you want a true zero clearance, and that's what this video is all about. So here are some older ones, right? Shop made, easy to do. Problem is they get chewed up. You get vibration from the blade, and after a while, it's really not a zero clearance anymore. So I set out to make a zero clearance insert that is just awesome. With a replaceable insert, you can change these out easily, and the actual insert itself doesn't even need levelers. Instead, I just used magnets. I started by getting a good measurement of the thickness of the material that I would need. Now, I want to start out by saying this was drawn and cut with a Shaper Studio and Shaper Origin, but you don't need a Shaper Origin or a CNC. It's a simple design. This can just literally be cut by hand. So here I am in Shaper Studio, and it integrates perfectly with the Shaper Origin, of course. It's the simplest way to draw things. You just create shapes. It could be squares, ovals, rectangles, and you can round corners, and then you highlight it all and take away the pieces that you don't want. It's literally that easy. Oftentimes I don't even use Inkscape or SketchUp because this is so much faster. And now I can just rename it. I'm going to call this Grizzly Plate, and from there I can just download it, and it goes automatically right to the machine, right to the Shaper Origin, and I'm ready to cut. So I started with some 15mm Baltic birch. I ran it through my drum sander to get it down the thickness that I needed. This will get covered on both sides with Formica, and Formica is about 35 thousandths of an inch. And so I just subtracted that from my overall measurement, and that should get me right on. That way I don't have to have levelers. Now, in my quest to keep my videos both appealing and informative to a wide audience, I'm going to blast through these Shaper Origin clips rather quickly. And there I use the Shaper support bar to get the material flush with the workstation. And here I'm going to scan. And you'll notice not only do I scan the workstation domino markers, I also scan the workpiece by moving the machine completely off the area. This will give you an image of that workpiece right on your screen. And those with a keen eye may notice that board with tape in the background. I should have moved that. It's not part of the actual scan, and it could confuse the Shaper Origin. I'll flip a 1/4 inch engraved bit to use the 1/4 inch shank to create a grid. I can then drop the bit down where it makes contact with the edge of the work to establish the X and the Y axis. And this is the bit I'll be using. It's a 1/4 inch upcut spiral. Yeah. Okay, so my actual board is 13 5/8. I can place this in the center of that. I could have put a pencil mark. I can go off these positions. My board's 13 5/8. I want to go center of that, which would be 6 13/16. So I just go to this X position. Back that out. We'll go negative 6.8125. Done. And 2 is the Y-axis. My board's 4 inches wide. My part is 3 13/16 wide, so it's under 4 inches, so it's going to center perfectly right there. We just hit this button, or this icon here, or the button on the handle, the green button, place. You can see even if I turn the machine, that part stays in the correct orientation. And we go to cut mode. So now you can see that gray line is the cut path. You can see the little marching ants, that's the direction of the cut, and the green line designates the part that we're after. You zoom out a bit here so you can see. It's awesome, right? Since I changed bits, I need to Z-touch again, even though the bit is correct at a 1/4 inch diameter. I'll set this completely on the workstation and go to Z-touch. The motor drops down until the bit makes contact. That establishes our Z-axis position. That's it. We're ready to cut. Then it's just a matter of moving this CNC controlled router in the direction of cut, keeping those crosshairs as close as you can to that dot on the dashed line, which keeps you in the corrective range that is defined by that white circle. This accounts for human error, so if you go outside that corrective range, the router will abort, which means the router spindle will automatically retract out of the cut. Amazing. The other thing is, even with a new bit, it'll leave a little bit of a burr that tends to create a little bit of drag on the bottom of the shaper origin. So I'll just hit that with a piece of sandpaper to get rid of that burr. You only have to do it on this first cut. I find that it's worth it just to remove that burr. It just makes a smoother travel with the router. Of course, this will be typical with an upcut spiral bit. And now we just place the crosshairs on that dot, and that's where the spindle will resume cutting. And yes, of course, you could take your original throat plate, use some double stick tape, attach it to a board, cut it close to the bandsaw, and then use a flush cut router bit to make this shape. All right, that came out great. Now we'll focus on cutting this insert area. Same thing, just follow the line. It's going to do it, and AutoPass is already set up. I think I baby the machine and bits a little bit more than most. It could probably be done in 1 or 2 passes. All right, here we go. And what's really cool, or another feature that's cool about the AutoPass function, is that the bit ramps down. You can see as it's not only plunging down, but it's also traveling. So that makes it easier on the bit instead of just plunging straight down. And here you can see as I'm in pass 3, we're approaching pass 4 of 4. And it tells you on the screen there. Then we reach our destination, designated by that dot within a dot, and the router spindle retracts automatically. All right, I actually goofed when I made the file. It's upside down because ultimately what I want to do, or what I'm going to do now, is cut a rebate all the way around. And I can do that right on board with the tool by creating an offset. So I'm going to do a 3/8 offset all the way around, and that will get an insert, which will be the zero clearance insert pieces. So I need to flip this over because this is actually the bottom, and I need to make that rebate all the way around in the top. So to not lose my place, I just cut a couple of blocks. Got some double stick tape, and I can index this right back into position, I believe. So if I can get this loose without disturbing those blocks, something like that. Let me let my my cat in. BRB. When it comes to double stick tape, I find it easier to try to scrape it to get it to release from the backer rather than trying to get in between them. Just kind of scrape it on a corner. That usually does the trick. Okay, so now, oops, my tape is in the way. So now I can index this. Wow. Right there. That should do it. So now we're going to create a 3/8 rabbet just by doing an offset, and I'll show you that on board. Okay, so there's a previous cut path, and this hole is in the same place. And so what I want to do is I want to go 1/4 inch deep, because that's the thickness of my insert material, my zero clearance insert material. So 1/4 inch. It's actually 1/4 inch minus the thickness of the Formica that I'll be adding. I'm going to be doing outside. I'm going to be doing an offset, and I want to, ultimately I want a 3/8 offset, but I only have a 1/4 inch bit. So I'll go 3/16. So I'll just do half of the offset at a time. And that needs to be a negative, actually. Negative 0.1875. There we go. I changed my mind. I decided not to go 3/8 wide. I went 5/16, just a tad less. All right, so I wanted to show you this. So that's the depth of the rebate or rabbet, and I did an offset of 0.313 or 5/16. All right, this is awesome. Check it out. So this will get the insert, right? You can see it's slightly proud because I'm going to cover this with Formica. So now that's nice and flush. So then I can just change these inserts out as they get worn. Yeah. Awesome. All right, so initially I was going to put some levelers, you know, some little Allen head. And then I thought, well, I can just make this the right thickness by sanding this down, you know, including laminate top and bottom. And so I'm just going to put magnets here, and I think it'll just latch in place really awesome. That's the goal anyway. And it doesn't quite fit, it's a little bit snug, but I'm not gonna worry about that just yet, because what I'll do is I'll cover it with Formica, both sides, then sand around the perimeter, and I know it'll drop right in. Since I'm going to be covering both sides with plastic laminate, I didn't feel the need to glue these magnets in place. The Formica will hold it in plenty strong. And the size of magnet that I used here are 1/8 of an inch thick by 1/2 inch round. So something to note, oftentimes plastic laminate, when it gets old, it will tend to curl really, well, it makes it hard to work with, right? So an easy way to do is to curl it to your advantage so you can keep one edge against the fence. Super easy, very effective. This contact cement is industrial grade Weldwood brand, and I get it from my old work. They buy it in drums of 55 gallons. All right, so this is tacked up a little bit. Just a little tacky, but it's not sticking to your finger. That's about right. I'll just lay these on here. I'm just going to put this between a heavy cowl and my bench and just smash it down for a little while. When working with plastic laminate, I prefer these low profile router bits. They don't have a bearing, just a pilot. Since there's no bearing, they don't clog with glue, and they're quite inexpensive. And here I'm just going to bang a hole right through this Formica. I mean, I guess you could drill a hole, but this is just fast, easy, and doesn't hurt anything. And you may laugh, but here's an alternative. Just let that pilot smoke its way through that Formica. It doesn't hurt a thing. Call me weird, but I kind of like the smell. It's probably toxic. All right, so check it out. So these router bits, these are solid carbide laminate cutters, right? No bearing, just utilizes a pilot. But this pilot is pretty tall. And so to route this in this rebate or rabbet, those router bits don't quite fit. So I had to grind this one down. This one is a straight cutter. This one's actually 7 degrees. I don't know if that shows up, but has 7 degrees when you're routing, you know, an adjacent edge, laminate to laminate. You would use this one. But anyway, this one is similar to that, but just straight and round on the end, but taller than 1/4 inch. This pilot is taller than 1/4 inch. It won't fit in these rabbets. So what I did is and they're solid carbide, so they're really hard. So I took a diamond cutoff wheel on my 4-inch grinder, and that took it down just enough to where I could fit inside that rebate or rabbet to route that laminate off. Always a way, yeah. I realized the magnets were pretty powerful and wanting to stick to the cast iron, so I just used this auxiliary plate that indexes in a hole and utilizes the T-slot. That's awesome, yeah? And I'll probably need to drill a hole here so I can get this out once the insert's in. So speaking of insert, I can now cut some pieces to fit in here. I'll just cut a bunch of them. And then I'm gonna drill some holes in the corners so I can anchor these down. So I've got some little inserts and some threaded machine screws. Rather than wood screws, I thought this, you know, if I used wood screws, eventually this would wear out. So yeah, happy with that so far. All right, I suppose I should have cut a few more, but that'll hold me over for quite a while, I think. I didn't have another piece of fall off of 1/4 inch. I would have had to have tapped into a full 4x8 sheet. But now I'm gonna cut or route the corners, and I'm just gonna gang these all together. I think it'll be easier this way. Just line them up like that. Nothing really critical. On this MDF, I actually grabbed the wrong router bit and used 1/4 inch round over, so the radiuses are a little bit too big on the insert pieces, but shouldn't matter. How awesome is that? So I did find some, it's not melamine, it's called a cold roll. So it's white on one side, right? But these will also work. And those radiuses match a little bit better, but not that it matters. I mean, big deal, right? For what they are, they're gonna get chewed up, sacrificial. But I kind of like the white. Reminds me of an orange dreamsicle. All right, so I have these little inserts. These are going to go in from the bottom, and then these zero clearance inserts will screw down, right? And I don't have a lot of room. I wanted to make this wider, but this is already getting narrow. So I think it'll work. I laid out where that screw will go and came up with 212, right? So I can just take my scribe. This is pretty high tech. I just put my calipers against the edge of the table here and somewhere in there. We'll do a layout on one of these MDF pieces. Does that show up? Yeah. So I can just mark that like that. Once I know that that is going to work, I can drill all the way through, set up a fence or whatever, and then drill them all to accommodate this size in the insert, and then put this threaded insert with this size bit coming up from the bottom. So pretty straightforward. So by the time of editing this video, by now I've been using this zero clearance insert for a while now, and I gotta tell you, I don't know what took me so long to make this. It's freaking fantastic. So of course, besides the added safety, the cuts just are a lot cleaner because you have the fibers of the board that you're cutting supported on each side of the blade. And you'll just notice that overall things feel better as you're making the cuts. All right, let me drop this blade down, and I guess we can get rid of this. Get rid of that guy. Check it out. Awesome, yeah? Gonna love that. So even if I have a bigger blade on here, like a 12-inch blade, so I have a non-ferrous blade, it's the only 12-inch blade I ever put on here, and it'll cut, you know, a little bit. It might cut the insert completely. It won't hit the screws. And the magnets are out of the way as well. That is awesome. Made a bunch of those. So yeah, fantastic addition to the shop. Oh, and I wanted to mention, if you make one of these, do yourself a favor. Here, let me grab a screw gun. Let me pull this insert out for a second. So I made this rebate 5/16 wide all the way around. In reality, it could be wider on the ends, on each end, so that these are not so close to the edge. See that? I didn't think of that, but that's what I would change if I made another one. This step here could really only needs to be about an 1/8 inch wide, and these could be a 1/2 inch wide at the ends. It doesn't need to be the same all the way around, but it's gonna work and work well. All right, so I ended up making 2 of these. This is the first one I made, and this insert I made with laminate on both sides. And then I thought, well, that was silly because that's just hard to cut through. And then I would have to, make a bunch of these. So that's when I switched to just melamine here. And I missed on the depth here, so I added some tape. And then I put levelers on this one. So there's magnets in there and levelers, and that works. And I thought, well, what if I just make it the right thickness to begin with? So no levelers on this, just magnets, and then this other insert. This one's a lot better. That is awesome. And at first I was making those at 1/4 inch, and they were just a little bit under or over. Yeah, over. And then this stuff, for whatever reason, is just a few thousandths under, and it has the white on one side. And so that is dead flush. Should work better. Yeah, man. Always improving. All right, there we go. If you make one of these, you will not regret the time that you spend. It is so good. Thank you so much for watching. Make your day amazing, yeah?